Okay, so we're trying to find the volume of the cap here from right here. So the distance from the bottom of the cap to the top is h. So from here to here, that's going to be h right there. So let's say that I decide to put the axis right here at the center of the sphere. Okay, so what that means then is that my the distance from the x-axis to the infinitely thin slice of water. I said water because it's blue, but anyways, you know what I mean. So a slice of the cap is a circle, and it's going to be located at the position y. Okay, so taking that into account, my task is now to figure out a formula for the area of the circular cross section. So to do that, I need to find this radius r right here. Okay, so to do that, I can draw a line from the center. I know that from the center to the outside edge of the sphere, I know that that's going to be capital R, because that's the radius of the sphere. Okay, so if that's r and the distance from here to here is y, then little r is going to equal to, by the Pythagorean theorem, the square root of r squared minus y squared. Right, so I'm looking at this triangle right here. So little r is square root of r squared minus y squared. Okay, so then what that means is that the area of the cross section, this cross section right here, is going to equal to pi times the radius, which is capital R squared minus y squared squared. Okay, so of course can simplify that a little bit. Area of the cross section is pi times r squared minus y squared. Okay, and so then what this means is that the volume then, sorry, let me pick a different color here, purple. Okay, so the volume is equal to the integral. Now here you have to be a little bit careful. Notice that your cap goes from here to here, and so what this represents is the limits of integration are going to be the y values that this corresponds to based on where I put my axis. So because I put my axis down here, then my integral is going to have to go from this point right here, the bottom of the sphere, which is going to be r, capital R, minus h, and it's going to go all the way up to r. So hopefully that makes sense. So this is r from r minus h to r, and this is of pi times the radius squared, which is capital R squared minus y squared dy. And so remember that the r squared is r is a constant, so the antiderivative of that is just going to be pi times r squared times y minus y to the third over 3. And this is going to be evaluated from r minus h to r. And so when all is said and done here, you're going to get h squared r minus h cubed over 3. And that's it. And I almost forgot times, of course, pi. Okay, and then that's it.